Hi, I'm Maxine Spencer, and this is my lab 3 for Physics 2. This is my circuit lab. Hold on, I'm gonna put it. There we go. So the purpose of this lab was to predict parallel and series circuit behaviors as they're impacted by resistors and capacitors, and to observe resistor and capacitor behavior. And so we found that the delta V, like the change in voltage across circuits, is always 0, and when resistance increased, charge and discharge time increased. So Kirchhoff's voltage law is that the sum of the voltage loop is 0, and Kirchhoff's current law is that the sum of I in is the same as sum of I out. And then, of course, I is equal to the magnitude of the change in voltage over R, that's for the resistor, and Q equals C times the magnitude of the change in voltage, that's for the capacitor. So this is our first circuit, which is our series circuit, which had the 47 ohm resistor and the 100 ohm resistor, and we had our 2 ammeters. So that's our setup right there. And then, of course, the 2 batteries at the top. And so for our data for this part, we got that for the ammeter part, the I1 is 18.3 milliamps. I2, I'm just going to say MA from here on out. I2 is 18.2 MA. And then when we reversed I1, we got negative 18.1 MA, which is interesting that it wasn't identical. But anyhow, and then when we looked at the voltmeter, the delta V was 2.8 volts, and the new I2 was 0 MA, because if you go back to that formula, we were confused about this in lab, but it was explained that since the resistance approaches infinity or whatever, then I would approach 0. Anyway, or sorry, since the voltage approached 0. Anyway, it was, I'm like blanking on the wording of it, but you know what I mean. Anyway, and then the potential differences for the 47 ohm resistor, it was 0.8 V, and then for the 100 ohm, it was 1.8 V. For the battery, it was 2.8 V. For the ammeter, it was 0, and the sum was 0.2. And so for the parallel circuit, it was 49.7 MA and 47.7 MA. Those were our 2 measurements there, and then that's our graph. So as you see, that's the minus 0.8, and that's the minus 1.8, and that's like the summation of that all. So yeah. For our second circuit, this is the RC circuit, and we found that the brightness decreased with both charge and with the discharge. And so bulb 1, 2 ohms, the charging time was 30 seconds, discharging time 32 seconds. Bulb 2 was 4.6 ohms and thus took longer. Time charging was 56.96 seconds. Time discharging was 58.36 seconds. It was interesting that discharging took longer than charging. I wasn't expecting that, but that was the case for our batteries. And so what if the charge capacitor, or what if you charge the capacitor with no resistor in the circuit? So in the ideal model, the charge would be instantaneous because there'd be no resistance, but that realistically is not possible because there's always going to be some kind of resistance, just like within the wire, even without there being a resistor there. Anyway, that's my lab. Thank you.